Hello, geometry kiddos. Today we are doing lesson 2-2, and we're going to be talking about inductive and deductive reasoning. So two different types of logics that we are going to be talking about. Remember, at any time during this, if you need time to copy it, just pause it. Go ahead and copy what you need to, or rewind it, fast forward, and do what you need to get all of your notes down. So make sure you have your title of 2-2 inductive and deductive reasoning. All right, when we look at here, there's some different patterns and some different things that you see here going on. So filling in by looking at patterns, we could fill in what should be in this box right here. So here's a simple one. So what color are geese is the question. So we have this picture of this goose. We have another picture, and now we have two geese here. So now, what color are geese? Geese are white. Look at all the geese, they're all white. And then what could happen is we come along and dun dun dun. What color is this goose? This one is not white, but using inductive reasoning, looking at the patterns, what we saw, we make a comment or a suggestion or something that happens, and we were guessing geese were white, and then all of a sudden we have this one come in, and this would be our counter example. So inductive reasoning is when you notice a pattern and assume it will continue, you are applying inductive reasoning. The conclusion that you draw is called a conjecture. So when you look at a pattern, and we just assume it's going to continue, that is called inductive reasoning. And the conclusion that we draw, so us saying the geese are white, that would be our conjecture. All right, to show that a conjecture is always true, you must prove it. To show that a conjecture is false, you only have to find one example in which the conjecture is not true. This is called a counter example. So I think we did a little bit of that in the last lesson. Sometimes it can be a drawing, sometimes it can be a statement, sometimes it can just be a number. So your counter example can come in many different forms. To make a conjecture, you try listing some examples or making a chart. So here, the sum of an even number is an odd number. So what now would we be able to conclude? What is our conclusion here, or our conjecture? So the sum of even numbers. So let's just take two even numbers. 2 plus 6 is 8. 22 plus 100 is 122. 36 plus 72, what's that? 108. So what can the sum of an I didn't even do what I was supposed to do. An even number and an odd number. So I totally didn't do it correct. I did two even numbers. So let's do the right directions. An even number and an odd number. An even number and an odd number. An even number and an odd number. What's this one? 181. Whoops, 181. So what can we conclude? That the sum is odd. So by looking at patterns and things that are happening here, we can make a conjecture that the sum is odd. All right, so we're going to look for a pattern, make a conjecture, and then we can prove it by giving examples or find a counterexample to make it not be true. So here we go. A laboratory contains 150 bacteria. After 20 minutes, the culture contains 300 bacteria. So what happened? In 20 minutes, what happened? It went from 150 to 300. So what happened there? So after 1 hour, the culture contains 1,200 bacteria. So what is the conjecture about the rate at which the bacteria increases? And most of you are probably going to come up with the conjecture that it doubles every 20 minutes. So that is our conjecture, and so we can look at the 20 minutes it's 150. Whoops, at 0, it's 150. And then after 20 minutes, it went to 300. And we know after 60, it's at 1200. Okay, so what's in between here to be able to happen? So at 40 minutes, what happened? If we double 300, it gets to 600, and now if you double it, get to 1200. So there is our pattern by seeing what's happening. So show the conjecture is false by finding a counter example. So they're telling you this conjecture is false. For all positive numbers, is this conjecture true? If we take n squared, is it going to be greater than n? So let's put in 5 and square it. Is that greater than just 5? So is 25 greater than 5? Okay, let's try another one. Let's put in 10 squared. Is that greater than 10? Is 100 greater than 10? And that's true. Oh, but they're saying that there's a counterexample. So what kind of number could I put in? So it's a positive number. Well, is 1/2 a positive number? And now if we square it, is that greater than 1/2? So what is 1/2 squared? What is 1/2 times 1/2? So is 1/4 greater than 1/2? And because this is false, there is your counter example. All right, deductive reasoning. So inductive was looking at a pattern. Deductive reasoning. Okay, deductive is more scientific. So deductive reasoning, have you guys ever played this game, Guess Who, and you would ask your people questions? Does the person have a hat on? And if the answer is yes or no, you would cross off either all the people with hats or all the people without hats on. So you are using deductive logical reasoning. So deductive reasoning is the process of using logic to draw conclusions from given facts, definitions, and properties. I'd say it's more scientific versus looking at just a pattern that's going on. So this is huge, the law of detachment. So what I always do is this. The law of detachment is taking a conditional statement, P implies Q. Then if P happens, your conclusion is going to be Q. So P implies Q, P happens, then we can guarantee that Q is going to happen. Okay, so if there's lightning, that's the first thing, so that's P. Then the soccer game is canceled, that's Q. So there is lightning, P happened. What can we conclude? We can conclude Q, which is that the soccer game is canceled. It followed the law of detachment, and so we can say soccer is canceled. All right, are these examples? So if two segments are congruent, so that's P, then they have the same length, that's Q. This is saying two segments are congruent, P happened, so can we make the conjecture that AB and XY, their lengths are the same, Q. So this is true, this is valid deductive reasoning. All right, if you are tardy 3 times, P, you must go to detention, Q. Shay is in detention, Q. Can we now conclude that she was tardy 3 times? Well, this one is P implies Q. Q, is that valid to now conclude P? And the answer is no, this is false. So, could you have gotten detention because you pulled the chair out from underneath someone? Could you get detention because you were running in the halls? So could you get detention for a different reason? And that answer is yes. So that's why this is faulty reasoning. All right, so law of syllogism. This is kind of 3 parts. So this is P implies Q. Then Q implies R, which is a new piece. So now, can you conclude that P implies R? So it's kind of like if 2 equals X and X equals Y, can you now conclude that 2 would be equal to y? Okay, so that's using the law of syllogism. So if it is Saturday, that's new, so that's P, then I get to sleep in, Q. If I get to sleep in, that's the same piece of information, so that's Q. Then it is a good day, that's a new, so that's R. So now we're saying it is Saturday, so P, what would that imply? Well, that's going to imply your R, so we can now conclude it is a good day. So that is using the law of syllogism. All right, so is this one a valid reason? So let's see, does it follow? P implies Q, Q implies R. So let's see, measure of angle A, so that's P. Then A is acute, that's new, Q. If angle A is acute, that's the same thing that we just had, so now we have Q. Then it is not a right angle. Well, that is totally new. That is R. So P implies Q, acute. Acute is new. Then it implies that it is right angle. So now, can we say, so is the conjecture, does it make sense? The measure of angle A, is not a right angle. Okay, so the measure of angle A, that is P. Then it is not a right angle. Did we get not a right angle, which is R? So yes, this is valid reasoning. Okay, so that's P, acute is new, that's Q. A is acute, that's new. New, not a right angle, that's R. So now can our conjecture be P implies R? And that's what happened. So we have some valid reasoning here. There's one more thing that usually pops up into your homework. So can you please check with this thing right here? So this one, normally it's P implies Q, Q implies R, so now the conclusion is P implies R. So if we switch it up a little bit and have P implies Q, R implies P, can we now conclude that R implies Q? And this is true. This is valid. So please get this one written in your notes because this will show up on a couple different questions here and you have to check it. Detachment must follow. P implies Q. P must happen. Then we can conclude Q. It must be in that order. If it's not, then it is not valid. All right, good luck on your homework. Lesson 2-2. Now, if you notice in there, I put 2-1 and 2-2 are not due until Sunday evening. So I'm giving you the full weekend. If you're busy Thursday, Friday, and want to hold off on some of that homework, don't get behind because you're not going to want to be doing 3 assignments on Sunday night. So make sure that you are working, but everything needs to be completed by Sunday night by midnight. All right, good luck on your homework.